Hello and welcome to our series 1 in YouTube. So friends, you know that we have already done the analysis process and now we need to do the model analysis, dynamic analysis, static analysis we have already done, and results intended results we already got. So now our purpose is do the dynamic analysis. So let me uncheck my model. Without unchecking I cannot do any modification. Just I have done uncheck my model. Just go define and model cases. Okay, so model cases, we need to modify model cases, and we need to actually my story is building is 2-story, so I will keep is 12 modes are enough. For per story you need at least 3 modes. So this is quite enough. If you go for higher modes, your software will take more time and take some load on it. So if you go higher modes, more than 3 per story, so it will be good enough. So this is your model analysis. So I'll type icon, it's okay. And mass source we have already defined. Let us check again. So model case frequency all is okay. You just go and non-linear case no. Use better modification. Okay. Non-iterative based dead loads, live loads, non-iterative it's okay. Just go okay and okay. And go the check the load cases. So we have add new load case. So this is okay. And let me change this response spectrum. Static analysis okay. So do the analysis. There is some error in the model, so let us ignore that small error. Okay, so we need to check the results, display story response plot. Okay, so this is our main objective for the dynamic analysis. So this is our step number 1, and response story response. Okay, and this is maximum story displacement. Now we have the add model 1 mode 1. So we have the formula 1 and calculate, and we have the story displacement. Okay, model. So this is our story response in a y direction. Okay, so this is in y direction story response. Maybe another mode there will be story response is more than y direction in the x in the global x direction. So this, let me check for the 12 mode. Okay, so this is the 12 mode. So like you can check for the 8 or 9 mode. So and I am going to check for mode 3. Okay, so in mode 3 the in both direction of the building is going to displace in its millimeters. It's up to 90 millimeters, around about 10 centimeter. Okay, its graph is looking very scaled one. So it's story 2. This is likewise you can check the maximum story drift. This is maximum story drift, and maximum story drift. And what's maximum story drift, you need to check and you need to Now about this overturning moment you can check, and how about the overturning moment? Shear, base shear, story stiffness you can check, and auto story check maximum shear, story shear. Okay, this is story shear. So let me check the story shear for the mode 1. Okay, this is mode 1 story. Uh, so from here you can check these all results. You can interpret the results, and ground floor. Okay, this is drift, and you know that the permissible limit of this story drift is about, I will show you in my tips. Okay, this is the total level response displacement. Okay, story drift here is here. Section formula, this is section formula. Response spectrum will define the formula. Yes, maximum calculated drift then when your time period is less than 0.5, 0.5, then 0.7 second, then it should be 2.5% of the total story height, and if it is greater than 0.7, it should be it should be 2% of the total story height. Okay, so you know how to calculate and how what will be the permissible limit of your, if your story is not within the permissible limit, then you need to revise and make increase your stiffness to avoid the more drift. So you can do that in different codes have different permissible limits, so you can revise your design, and you can design again a safe and economical design. So this is all about the story drift and model analysis, because there are two confusions, that static analysis and model analysis. Static analysis is based on your demand and what type of how much reinforcement required, what type of size is okay or not okay with the frame structure. But in drift, in the dynamic analysis, you need to check the whether the permissible limit of the drift, and how much the story stiffness is okay, and how much the story displacement is okay. This is cause also ponding effect as well as instability, unserviceability, increase unserviceability of the building. So now we check this option, and we have the, you know that uh, the table display theory plot. So this we have already done. We need to check this table, design, model, analysis, results, displacement result, direction results, and frame structure results, all results, virtual energy result, time history, response spectrum function, analysis, load combination, load cases. Okay, this is what result we are intended to find out, that base shear for EX. You know that EX direction is more Fy base shear, because the mass is same, so base shear should be same, but direction may be changed for the EX and EY. Okay, so these are the results for the response spectrum. The response spectrum results based on the response spectrum. Okay, so this 28. So base direction, design direction, we can find out the design direction, needed load, acceleration, velocities, drift, we can find out the drift. So for further detail you need to go through your literature to understand the very basic and practical use of ETFs. For time